AFCI, or arc fault circuit interrupter cable, is an electrical cable engineered to detect and interrupt arc faults, a frequent cause of electrical fires. This cable is commonly used in bedrooms and other areas with an elevated risk of such fires. A typical AFCI cable is 14 gauge and comprises 4 conductors. These are a white conductor with a black tracer, a black conductor, and a red conductor. The white conductor serves as the neutral conductor. The white conductor with a black tracer functions as the equipment grounding conductor. The black conductor is the hot conductor, and the red conductor is the traveler conductor. Installing AFCI cable is similar to installing standard electrical cable. However, it is crucial to use AFCI cable in conjunction with AFCI circuit breakers. These breakers are specifically designed to trip upon detecting an arc fault. AFCI cable, while a relatively recent innovation, is gaining popularity due to increasing awareness of the hazards associated with arc faults. For those seeking to enhance home safety, AFCI cable presents a viable solution. To further elaborate, let's delve into each component and its purpose. The white conductor, as mentioned, serves as the neutral. In an electrical circuit, the neutral wire provides a return path for the current, ensuring that the circuit is complete. The white wire must be properly connected to the neutral bus bar in the electrical panel for the system to function safely and correctly. The white conductor with a black tracer is the equipment grounding conductor. This wire provides a path for stray electrical current to return to the source in the event of a fault, such as a short circuit. Grounding is a critical safety measure because it helps to prevent electrical shock and minimize the risk of fire. The black conductor is the hot conductor. This wire carries the electrical current from the power source to the electrical device or appliance. It is essential to handle the black wire with caution, as it is energized and can cause electrical shock. The red conductor is the traveler conductor. This wire is typically used in 3-way switch circuits, where 2 switches control a single light fixture. The traveler wires allow the current to flow between the 2 switches, enabling either switch to turn the light on or off. When installing AFCI cable, it's important to adhere to all relevant electrical codes and regulations. This includes proper wire sizing, correct connections, and appropriate grounding techniques. If you are not comfortable working with electricity, it's best to hire a qualified electrician to handle the installation. Now, let's discuss AFCI circuit breakers in more detail. These breakers are designed to detect arc faults, which are dangerous electrical discharges that can occur when electrical insulation breaks down or when wires become loose or corroded. Arc faults can generate intense heat, which can ignite nearby materials and cause a fire. AFCI circuit breakers use sophisticated electronics to monitor the electrical current and detect the telltale signs of an arc fault. When an arc fault is detected, the breaker trips, cutting off the flow of electricity and preventing a fire. There are 2 main types of AFCI circuit breakers. Firstly, branch/feeder AFCI breakers, and secondly, combination AFCI breakers. Branch/feeder AFCI breakers protect against arc faults in the branch circuit wiring. Combination AFCI breakers provide both branch/feeder arc fault protection and also protection against series arc faults, which can occur within appliances or devices plugged into the circuit. When choosing AFCI circuit breakers, it's important to select the correct type and rating for the circuit you are protecting. The breaker rating, measured in amps, should match the ampacity of the circuit wiring. Using a breaker with too high of a rating can overload the wiring and create a fire hazard. AFCI protection is often required by electrical codes in specific areas of the home, such as bedrooms, living rooms, and dining rooms. The goal is to provide enhanced protection against electrical fires in areas where people spend a lot of time and where there is a higher risk of ignition. While AFCI cable and AFCI circuit breakers provide a significant level of protection against arc faults, it's important to remember that they are not a substitute for good electrical safety practices. Always inspect electrical cords and appliances for damage, avoid overloading electrical outlets, and never use extension cords as a permanent wiring solution. Proper electrical maintenance and awareness are essential for preventing electrical fires and ensuring the safety of your home. Furthermore, consider the specifics of the Massachusetts Electrical Code, as that is the location specified. While AFCI requirements are generally consistent across the National Electrical Code, local amendments or interpretations may exist. It would be beneficial to consult with a licensed electrician familiar with Massachusetts regulations to ensure full compliance. Beyond the basic understanding of AFCI cable and breakers, there are practical considerations for installation and troubleshooting. For example, proper termination of the equipment grounding conductor is crucial for the AFCI system to function effectively. This includes ensuring a secure connection to the ground bus bar in the electrical panel and proper bonding of metallic enclosures. Additionally, AFCI breakers can sometimes nuisance trip, meaning they trip even when there is no actual arc fault. This can be caused by various factors, such as electrical noise from certain appliances or devices, or by improper wiring. Troubleshooting nuisance tripping can be challenging, but it typically involves systematically checking the wiring, connections, and appliances in the circuit. In some cases, it may be necessary to replace the AFCI breaker with a different model or type. The red traveler wire, as mentioned earlier, is important for three-way switch circuits. In a three-way switch setup, two switches control a single light fixture. The traveler wires, which are connected to the traveler terminals on the switches, allow the current to flow between the switches, enabling either switch to turn the light on or off. When wiring a three-way switch circuit with a AFCI cable, it's important to correctly identify and connect the traveler wires. If the wires are not connected properly, the switches may not function correctly, or the AFCI breaker may trip. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any doubts or concerns. Electricity is unforgiving, and mistakes can have serious consequences. When dealing with AFCI technology, it's also helpful to understand the different types of arc faults that can occur. Firstly, series arc faults, and secondly, parallel arc faults. A series arc fault occurs when there is a break or discontinuity in a single wire. This can happen, for example, if a wire is damaged or if a connection becomes loose. A parallel arc fault occurs when there is a short circuit between two wires. This can happen if the insulation on the wires is damaged or if the wires come into contact with each other. AFCI circuit breakers are designed to detect both series and parallel arc faults, providing comprehensive protection against electrical fires. As technology advances, AFCI devices are becoming more sophisticated and reliable. Newer models may include features such as self-testing, which automatically checks the functionality of the breaker, and enhanced diagnostics, which can help pinpoint the cause of nuisance tripping. Keeping up with the latest developments in AFCI technology can help you make informed decisions about electrical safety in your home. To summarize the information, AFCI cable and circuit breakers are essential components of a modern electrical safety system. They provide enhanced protection against arc faults, which are a leading cause of electrical fires. By understanding the principles of AFCI technology and following proper installation practices, you can significantly reduce the risk of electrical fires in your home. It is worth considering a whole house surge protector in addition to AFCI protection. While AFCI protects against arc faults, a surge protector safeguards against voltage spikes that can damage electronic devices. These spikes can originate from lightning strikes, power grid fluctuations, or even internal sources like appliances turning on and off. A whole house surge protector is installed at the main electrical panel and diverts excess voltage away from sensitive electronics, preventing damage and extending their lifespan. Furthermore, consider the importance of regular electrical inspections. A qualified electrician can identify potential hazards such as loose wiring, overloaded circuits, and outdated electrical components. Regular inspections can help prevent electrical fires and ensure the safety of your home's electrical system. During an inspection, the electrician will typically check the electrical panel, wiring, outlets, switches, and grounding system. They may also use specialized equipment to test the functionality of AFCI breakers and other safety devices. Finally, it's crucial to educate yourself and your family about electrical safety. Teach children about the dangers of electricity and how to avoid electrical hazards. Make sure everyone in the household knows how to respond in the event of an electrical emergency, such as a fire or an electrical shock. By taking these steps, you can create a safer environment for yourself and your loved ones. In the context of bedrooms, where a AFCI cable is commonly used, consider the specific electrical demands of these spaces. Bedrooms often contain a variety of electronic devices such as lamps, televisions, computers, and chargers. These devices can draw a significant amount of power, and it's important to ensure that the electrical circuits are adequately sized to handle the load. Overloading circuits can create a fire hazard, so it's best to consult with an electrician to determine the appropriate circuit capacity for your bedroom. Another factor to consider in bedrooms is the use of extension cords. Extension cords are often used to provide power to devices that are located far from electrical outlets. However, extension cords can be a fire hazard if they are not used properly. Avoid overloading extension cords and never use them as a permanent wiring solution. Instead, consider installing additional electrical outlets to meet your power needs. Also, inspect extension cords regularly for damage, such as frayed wires or loose connections. If you find any damage, replace the extension cord immediately. Furthermore, be mindful of the placement of electrical cords in bedrooms. Avoid running cords under rugs or furniture, as this can damage the insulation and create a fire hazard. Keep cords away from heat sources, such as radiators or space heaters. And never nail or staple cords to walls or baseboards. In addition to AFCI protection, consider the use of tamper-resistant receptacles in bedrooms, especially if you have young children. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots, reducing the risk of electrical shock. These receptacles are required by electrical codes in many areas, and they are a simple and effective way to enhance electrical safety in your home. When making electrical upgrades or repairs in your home, always use qualified electricians. Unqualified individuals may not be familiar with electrical codes and safety practices, and their work can be dangerous and potentially illegal. A qualified electrician will have the necessary training, experience, and insurance to perform electrical work safely and correctly. Before hiring an electrician, check their credentials and ask for references. Also, make sure they are licensed and insured. A licensed electrician has met the requirements set by the state or local government to practice electrical work. Insurance protects you from liability in the event of an accident or damage. Remember that electrical safety is an ongoing process. It's not enough to simply install a AFCI cable and circuit breakers and then forget about it. You need to regularly inspect your electrical system, educate yourself and your family about electrical hazards, and take steps to prevent electrical fires and shocks. By being proactive about electrical safety, you can create a safer and more comfortable home for yourself and your family. Also, think about the impact of technology on electrical safety. As our homes become increasingly filled with electronic devices, the demand for electricity continues to grow. This puts a greater strain on our electrical systems, and it increases the risk of electrical fires and shocks. It's important to be aware of the electrical demands of your devices and to take steps to ensure that your electrical system is adequate to handle the load. Consider using energy-efficient appliances and lighting, and avoid overloading circuits. Another technological advancement that can enhance electrical safety is smart home technology. Smart home devices, such as smart outlets and smart circuit breakers, can provide real-time monitoring of your electrical system and alert you to potential problems. For example, a smart outlet can monitor the power consumption of a device and alert you if it is drawing too much current. A smart circuit breaker can detect arc faults and other electrical problems and automatically shut off the power to the affected circuit. Smart home technology can provide an extra layer of protection against electrical hazards and help you manage your energy consumption. When it comes to protecting your home from electrical hazards, AFCI cable and circuit breakers are essential tools. By understanding how these devices work and following proper installation and maintenance practices, you can significantly reduce the risk of electrical fires and shocks. Remember to consult with a qualified electrician for any electrical work, and always prioritize safety when working with electricity.